Hey there, how are you guys doing? My name is Andrea Rivera, and I'm gonna talk you guys about the collapse of the Quebec City Bridge in 1907. So let's see the history behind the collapse of this bridge. So the Quebec Bridge was 20 years in the making, from the founding of the Quebec Bridge Company in 1887 to the bridge's collapse in 1907. A cantilever bridge was proposed as the most feasible design to bridge the harsh, icy waters of the St. Lawrence River. The bridge collapsed during construction on August 29, 1907, killing 75 workers. Only 11 workers survived, and they were found alive. Some bodies were never found. A second attempt to bridge the St. Lawrence River was made. However, it also suffered a partial collapse when the middle span fell into the river. Again, 13 workers were lost. In the second collapse, the bridge was finally completed in 1917 and stands until today. So let's see the conception, design, and construction. The St. Lawrence River was the main channel of trade for Quebec during the summer, but during the winter it fell with ice and trade was completely cut off until the river ice over and travel was possible again across the dangerous icy bridge. The desire to bridge the St. Lawrence River was fueled by Quebec's need to be competitive in trade. The St. Lawrence River was approximately 3.2 kilometers, that's about 2 miles, wide at its narrowest sections. Its waters were about 58 meters deep at its middle. The velocity of the river reached 13 or 14 kilometers per hour at times, and the tides ranged as high as 5 meters. During the winter, ice became stuck in the narrowest part of the channel and peeled up as high as 15 meters. That's like 50 feet. Interest in building the Quebec Bridge arose as early as in 1850. However, the project did not gather momentum until 1887, when a group of businessmen and political leaders came together and formed the Quebec Bridge Committee. Due to the high level of interest in the project, the Canadian Parliament passed an act which incorporated the committee into the Quebec Bridge Company with 1 million capital and the power to issue bonds. The company now faced the problem of financing the Great Bridge. Government funding was requested. However, no money could be awarded for the project until the bridge site was selected. With some financial help from the local Quebec legislature, preliminary surveys were made. In 1898, after years of debate, the Caudier site was selected from the 3 recommended sites to be the location of the Quebec Bridge. With the site selected, bridge designs proposals poured in, on June the 16th. Okay, so let's see the collapse. So the events that lead to the collapse, as the bridge was erected, workers and supervisors found noticeable midpoint deflections in some of the cords. When the workers tried to rivet the joints between these cords, the pre-drill holes did not line up. In addition, bends were observed in some of the most heavily loaded compression members. Over time, some of the members' deflections increased. Deflections were first noticed as early as mid-June and were reported to Cooper by his own site inspector Norman McClure. Compression members had been cambered so that under load the joints could line up and could be riveted together. However, some of the joints failed to close. Both men presumed that the relatively small deflections had occurred due to some unknown pre-existing conditions. They were not alarmed, and they didn't put attention to those fails failures in the deflections. A disturbing pattern was emerging. Then members under the highest compressive loads were gradually buckling. These were built up with latticing, and as they deflected higher, stresses were placed on the latticing as well as the rivets attacking the lattices to the main compression members. Some of the engineers were unconcerned about the problem, believing that it was nothing serious. Others were still insisting that the bends were the result of the pre-existing condition. The manufacturer guaranteed that all the members had been perfectly straight when they left the yard. So let's see the causes of the collapse. So the collapse of the Quebec Bridge resulted from the failure of the lower cords in the anchor arm near the main pier. The failure of these cords was due to their defective design. We do not consider that the specifications for the work were satisfactory or sufficient. The unit stresses, in particular, being higher than any established by past practice, the specifications were accepted without protest by all interested. A grave error was made in assuming the dead load for the calculations at too low a value and not afterwards revising this assumption. This error was of sufficient magnitude to have required the condemnation of the bridge, even if the details of the lower cords had been of sufficient strength, because if the bridge had been completed as designed, the actual stresses would have been considerably greater than those permitted by the specifications. These erroneous assumptions was made by Mr. Sherlapka and accepted by Mr. Cooper intended to hasten the disaster. The loss of life on August 29 of 1907 might have been prevented by the exercise of better judgment on the part of those in responsible charge of the work for the Quebec Bridge and Railway Company and for the Phoenix Bridge Company. The failure on the part of the Quebec Bridge and Railway Company to appoint an experienced bridge engineer to the position of chief engineer was a mistake. This resulted in a loose and inefficient supervision of all parts of the work on the part of the Quebec Bridge and the Railway Company. The work done by the Phoenix Bridge Company in making the detailed drawings and in planning and carrying out the erection, and by the Phoenix Iron Company in fabricating the material was good, and the steel used was of good quality. The serious defects were fundamental errors in design. The professional's knowledge of the present day concerning the action of the steel columns under load is not sufficient to enable engineers to economically design such structures as the Quebec Bridge, a bridge of the adopted span that will unquestionably be safe can be built, but in the present state of professional knowledge, a considerably larger amount of metal would have to be used than might be required if our knowledge were more exact. So, in conclusion, the fall of this massive bridge can be traced back to several technical factors. The top and bottom cords for the anchor and cantilever arms of a bridge were typically designed as straight members. This common practice made the fabrication of these members easier. The bottom cords for the anchor and cantilever arms in the Quebec Bridge were slightly curved, as shown for aesthetic reasons. This added difficulty to the fabrication of such an unusual large members. The curvature also increased the secondary stresses on the members, reducing their buckling capacity. According to a letter writing to engineering record, as a rule, secondary stresses are much more dangerous in compressions than in tension members, which seem to have been the first to give way in the Quebec Bridge. So the cause of the failure. Another concern during the erection of the bridge was the joints. The ends of all the cords were shaped to allow for the small deflections that were expected to occur. When the cords came under their full dead load, these bad splices were bolted to allow for movement. The splices initially touched only at one end and would not fully transfer their load until they had deflected enough for full bearing at the splices. At this point they were to be permanently revived in place. The result was to be a rigid joint that transferred loads uniformly across its area to ensure only axial loading. Great care had to be taken while working around these joints until they were revived. Adding to these design problems, Cooper increased the original allowable stresses for the bridge. He allowed 145 MPa for a normal loading and 165 MPa under extreme loading conditions. These were questioned by the bridge engineer for the railways and canals as being unusually high. The new unit's stresses were accepted based solely on Cooper's reputation. Cooper developed an allowable compressive stress formula based on the slenderness ratio of the member. Bridge. The Quebec Bridge was an enormous structure, and very little was known as to how it could behave mechanically. The Quebec Bridge Company lacked funding to adequately perform testing. Cooper had required extensive tests on the I-bars, which form major tension members in the top cords. He did not require the compression members to be tested. Later, Cooper would state the reason for this as being, "There is no machine or method existing by which any such test could be made." However, when the company did finally secure funds for testing, Cooper rejected the idea, stating that too much time had been wasted already. Another oversight was that the stresses were not recalculated once Cooper increased the span from 487.7 to 548.6. The stress calculations were based on the span dimension. Once this error had been discovered and brought to Cooper's attention, he immediately made an estimate of the new stresses that would occur. He found that they would be approximately 7% more. Weights were then recalculated from the new information. They were found to be as much as 10% in excess of those previously calculated. The initial design weight for the bridge was expected to be 276 million mm, or 62 million pounds. The real weight of the bridge was estimated 73 million pounds, an increase of 18%. So we can see that in the rush following the final financial arrangements of 1903, the necessity of revising the assumed weights was overlooked, both by engineers of the Phoenix Bridge Company and by those of the Quebec Bridge Company, with the result that the bridge members would have been considerably overstressed after completion. Thank you very much for your attention. I hope you guys enjoy and you learn something about the big errors or fails that you can make whenever you are uh, carrying out a bridge. Thank you very much. Have a great day. I hope to see you next time. Bye bye.